Hello everyone, it is July 26, 2022 still. This is Geo-Rant 174, and I am going to continue with my Mars stuff here a little bit, but before I get into this, I got to make a little disclaimer like I did in the previous video. Like I am not an expert on Mars in general, I am not an expert on every type of remote sensing. I pretty much know seismology, aeromagnetics, and gravity anomalies. This other, I'm familiar with LiDAR, but this other stuff, like infrared and stuff like that, and this laser-induced breakdown spectroscopy, or LIBS, I'm not very familiar with, but I got the gist of it. And that's what we're going to talk about here, because I want to talk about problems with remote sensing in general, and at least problems I foresee. And any of you that know, there's a group of people out there that want boots on the ground on Mars, and a large majority of them are geologists, and this is why. I'm going to try to get into that a little bit here. First of all, the rover is currently taking cores, from the Zero crater. I love that name. And it's setting them aside to be picked up later. Now, that is very inefficient, and it takes, I know time is money, but time you can't get back. And this is going to take, assuming it even works, is going to take decades, if not a couple generations. So we're talking, at best 15 years, at, maybe 15 to 50 before we start getting any real concept of what's going on from these cores. And not to mention, the first core the thing drilled, it drilled into loose sediment and it fell out. Now, if I had boots on ground, I wouldn't make that mistake. I'd be able to tell it was loose. This is a robot, all right? It's limited. It's not a tricorder from Star Trek. It's not a magical detection device. And I'm sorry, my little rover here kind of looks like a Decepticon mated with a Red Ryder wagon, and an abomination occurred. But I'll get into that a little bit too. Remote sensing is very limited. When we do geology here on Earth, there's a whole bunch of subdisciplines, and I've talked about these before: structure, stratigraphy, tectonics, geophysics, geochronology, geochemistry, paleontology, which is a non-issue as far as we know on Mars, and stuff like that. Now, all these things come together, and many of you have probably seen geologic maps, all right? And you can't make those, especially 7.5 minute angle, 7.5 minute quadrangle maps from remote sensing. You need boots on the ground to do that. You need things like deep cores, good outcrops, stuff like that. You need people who have this, because when it comes to geologic interpretation and mapping in the field, we are still far, far ahead of these things. This technology is nowhere close to doing what we can do. And, we can do all the remote sensing we want, but I can pick up a rock, if I was on the surface of Mars, break out my hand lens and go, that's not relevant. Move along, that's float. Or pick up one and be like, from a rock outcrop, and be like, oh, this is interesting. I see stuff that resembles, sand grains and stuff like that. So sand stuff, and start working things out and realize that's important. I can do all of this within a couple of minutes. And that way I could discriminate which samples might be important for my purposes. This can't do that. And many of you have heard me rant about how I don't like identifying rocks from pictures. And the reason for that, and we've all seen these pictures of Mars, there's all this speculation as to what these things are. Just so you know, yes, bedding occurs in sedimentary rocks, but it can also occur in lava flows. As a matter of fact, it's one way to tell if you have a lava flow as opposed to a sill, if you don't have very good exposure. This can't do that, okay? And people look and they see things like bedding and cross bedding, and they go, oh, that's sedimentary. It probably is. That's exactly like it is. And this is massive. Oh, that's got to be igneous. Well, no, I could take you to massive sandstones. You know, it's faster, more efficient to have a human being on the ground. And this thing's never going to be able to make a geologic map, at least not in the next 50 to 100 years. These things, they're not efficient enough. You need to be able to analyze and deduce and things like that, which is something this can't do. But before I start digressing too much, let's talk about one of the remote sensing methods. And then I'm going to talk about why I don't like it, but you know, maybe I don't understand it fully. This LIBS. Now basically, the rover sends out a laser beam, pew, heats that little 0-dimensional point to about 10,000 degrees, because a point has no dimensions. It gives off plasma, and which excites the atoms so it can get emission lines. I think that's how it works, and identify elements, kind of in a similar way we do with the sun, which is also another form of spectroscopy. It's a whole thing. There's tons of different methods, but this is a specific type. But the problem with that is that identifies elements. All right, yeah, so. But if any of you have seen me do any of my rants before, you have minerals which make up rocks, which are made of elements, chemical compounds, and minerals have crystal facies. This can't analyze any of that. So if you get a bunch of data back with a bunch of elements, maybe you can do molecules to a limited degree, I don't know. But that doesn't tell you, that just gives you the chemistry of the rock. It doesn't tell you what the rock is. I can... I'm going to get into that here in a second, but first I want to talk about, like this. Let's get into this here. Carbonatite, CaCO3, like carbonate rocks, limestones, and dolostones. But this is igneous. And often the texture of mineralogy is similar to marble. So if you're just pew-pewing this, and you get back calcium, carbon, oxygen, you could get back sodium, calcium, things like that, you might be, like that might be anhydrites in it or something. But in reality, you could have feldspars in there, and this could be a carbonatite, not a limestone. All right, so this can't analyze crystal facies at a distance. It's not a magical tricorder. Okay, there's other problems I think that we can run into with this too. So you get all these elements, and the plan is to send that information back to Earth and have a bunch of students, hopefully they won't mess it up, try to sit there and analyze, what is it likely based off what we have here on Earth, which is another problem in and of itself. Yes, the Martian surface does resemble Earth's surface to a large degree, but the planets are not synonyms. All right, we don't have a CO2 atmosphere anymore. I talked about that in the last Geo-Rant. So they're going to mess it up. In my opinion, I can foresee there being problems with the analyses here, or coming to incorrect analyses, which is fine. It happens, but there's boots on ground. You won't have any of these problems. I know, launching humans into space for a couple of years, down there for weeks, a lot of time, and all of that fun stuff, and it's very expensive, yeah, but it's not as much time as this takes. So this is pew-pewing, sending information back. Say it does this 200 times to the sauerkraut. Just a bunch of elements, molecules floating around. Don't really know what's where. Now, there's another problem here too. If I'm pew-pewing this, generate some plasma, and I get things that resemble our iron, magnesium-rich minerals, or elements like, that make up minerals like olivine and pyroxene, I might conclude that this is igneous. I might sit there and be like, oh yeah, this is probably a lava flow of some sort. But what this little guy isn't doing, and taking all these little 200 points, which probably would take a few hours and I could do it in about 30 seconds, is going to not tell you anything about the grain size. This could be granular, rounded, even though it has that in it. It's something you've heard me talk about before. A gray wacky, which is actually a lith wacky or lithic arcosic wacky, sandstone. It's a sandstone derived from nearby volcanic units. This, I don't see how this can discriminate that. All right, and you see things like crossbeds in here, and you might be like, oh yeah, that's a sandstone. So it pew-pews it and it comes by. It's mostly silicon and oxygen. Chances are, since it's cross-bedded, that's what it is. It's a quartz arenite sandstone. So we got this one right. We failed here. We're pew-pewing this, and we get some stuff that resembles mudstones. Okay, we get a lot of stuff that could be interpreted as feldspars and stuff. So we sit there and say this is a shale. But if we had boots on ground, we could look at it and we have a similar problem to this and see that, well, technically it is a sediment, but these laminations are pyroclastic. So this is some sort of tuff. So we screwed up here. We have a wacky here. I'm just going to put sandstone. That's what it actually is. A rover called it this, so our rover fails here. This is a tuff, but our rover called it a shale, so it failed here. That's the interpretations we're getting. So we have this little bit of quartz arenite between two igneous units. And you can get bedding or not bedding. So our rover, we have a sandstone, technically, but it's a gray wacky-ish type thing. We have a quartz aranite here, and we have a tuff here, but our rover has failed 2 out of 3. I foresee this being a massive problem. Another thing, too, we'll just say, for the sake of argument, that this is all sedimentary, all right? We'll just say it does a thing. You know, this comes out a good quartz aranite, so does this, and this comes out, you know, maybe a limestone or something like that. It gets it right, but we have no way to verify that. Just sake of argument, it does. Now, this thing cannot make a geologic map. How do we interpret this? Well, if it is sedimentary, the beds are angling. How could the beds be angling? Well, there's a couple ways this can happen. Now, using Steno's laws and looking at this, we can't deduce necessarily, but it is a possibility that something is limited like this, that this is a wind-blown deposit. Well, we'll just say these are all sandstones, okay? It's all sand. And so this could have been the leeward side of a dune. This could have been a small, like, eroded channel, you know, some water came down and just eroded it a little bit. And then we get more massive dune deposits on top, meaning that this thing was a big dune on top of another dune, okay? Or if this is a mudstone and this is a limestone, this didn't get deposited like this. This isn't something that happens. This shows tectonic alteration. And I think that dip, you know, if you go by the dip, here's our horizontal dip, that looks to be about, I don't know, that could be 25 to 30 degrees. All right, I don't know for sure. So according to the law of regional horizontality, with things like lake deposits, sea deposits, you know, marine deposits, this can't happen unless you have an alluvial fan. And that's another thing. What if this is a conglomerate? Anyway, some of you would notice that I've modeled this after a certain picture, which will be my next Geo-Rant. But that one doesn't seem that. I mean, conglomerate is the kind of thing you can kind of see from a distance. So we have this dip, which means something tectonically moved this. Well, what does that mean? Well, say this thing does its thing. This takes a day or so to get the information, get sent back, and spends a bunch of time. I don't know how long it takes these things to move. Maybe a week or so going 50 meters, 100 meters. And it hits another outcrop with this same unit coming up out of the ground like this. It pews all of that just to come to the conclusion that this is similar to that, but not exactly the same. Well, what we would have is a syncline. I could walk that distance, start making a geologic map, and come to that conclusion 50 meters to 100 meters, you know, within an hour. And this thing's already at weeks, okay? And I can see I have a syncline. And something else I can do that this can't do. I walk over here and say, I see a little tiny bit of that sandstone over here and this is my bedding surface. Say I got ripple marks or something like that. And I take a measurement and I get, about 30 degrees. Similar to this, lithologically, these are are exactly the same. The rover doesn't notice it. It sees it as a parking block. I come to the conclusion that, I can dig down a little bit too, and if I get down deep enough, which is something our rover can't do, but I just need to make a little trench, and I get to the bottom of this, and I start seeing this cross-bedded stuff. That tells me that this is the same as this, but it's down here. That also tells me is I have a fault somewhere in here. This is relative up, relative down. Something you do when you're in the field making geologic maps and taking strikes and dips and things like that. This can't do any of this, okay? All it can do is what it's programmed to do, what it can be commanded to do, and what tools it has. So as a human being, I can do far more. In the time this is pew-pewing the rock and taking 200 measurements, I can do all this and come to this conclusion. I can make a small geologic map of maybe, 100 meters by 100 meters and realize there's a syncline in here, there's a fault here, and all this stuff in a couple of hours if I'm proficient at what I'm doing and I'm familiar with the local geology. We can't do most of this. So what it can do is going to take forever. So this isn't really a geo-rant about me ranting about, or trying to teach you something. It's me having concerns and showing you why geologists, in particular, want boots on the ground at Mars. Because if we just wait for technology, well, there's no guarantee technology is going to be able to do any of this efficiently ever anyway. And even if it does, we're still looking at 100 years down the road or so. It's far in the future. It would be, that time you can't get back. Once that time's gone, you're done. Money comes and goes. It's money. I hate it and it's stupid in my opinion. But anyway, that comes and goes. But everyone focuses on the money and doesn't realize the time that's involved, and then not even being able to interpret the data properly. So anyway, that's it. Feel free to leave any comments or tell me I'm absolutely wrong on how this is doing this and the spectroscopy, the libs or whatever. But as far as I know, that's it. And like I said, I'm not familiar with most of this stuff, also including infrared. I don't know any details about that. I don't know if there's a remote sensing way to actually get crystal facies. I don't know that, all right? But stuff like that may be in development, but still, that's still not going to get you this. Anyway, that's it. Go ahead and leave comments if you want, and have a good day.